Hey guys, Mr. G here. We're going to continue looking at graph transformations for trig functions. In the previous video, we took a look at the change of the amplitude and the period, giving the numbers for A and B. All right. Now for this video, we're going to take a look at what kind of transformations are going to happen when given a number for C and or D. Now those two are going to be a certain kind of shift, specifically a horizontal and or a vertical shift. So we have y equals to a times sine of bx minus c plus d. All right, and this could be also applied for cosine. So you guys recall the absolute value of a represents the amplitude, and to figure out the period, we can take 2 pi or 360 and divide them by the number given for b. All right. So now, what I want to talk about are the two shifts that applies for C and D. Now, C is going to be applied for the horizontal shift, or in this case, a phase shift. Since we're working with trig functions, we're going to call it a phase shift. Now, for this one, we're going to take the number that represents C and then divide it to my B. All right. So even though we call this a phase shift and it has its own formula, it still follows the same rule for a horizontal shift. We always follow the opposite sign of whatever we're given. And then D represents the vertical shift, nothing new. However, it does give us the value for the midline. And then we're able to use whatever we're given for D and the number for A to calculate the max line and the minimum line. All right. And then also, just wanting to talk about quarters. So after you figure out the period of the graph, then we're going to take that period divided by 4, and that's going to tell us the distance between each x value. Now, before we get into the examples, let's recall the two graphs for the original sine and cosine functions. All right. So for the sine, we're starting off at 0, 0. Then we go to 90, 1, 180, 0, 270, -1, and 360, 0. We could actually describe a pattern for this graph. So all of the lines that are on the x-axis are going to represent the midpoints. And we have our maximum points and minimum points. So we're going to define the pattern as mid, max, mid, min, mid. Again, it is mid, max, mid, min, mid. And then we have the graph for cosine, which is 0, 1, 90, 0, 180, -1, 270, 0, 360, 1. And the pattern will go max, mid, min, mid, max. Again, it is max, mid, min, mid, max. All right, so we're going to be using the patterns for the original graphs to help us graph our new functions. All right, so let's start off with, all right, so let's take a look at the first example where we have y equals to cosine of x plus 90. Now, if we were to compare the function that we're given to the setup of the graph transformation function, and this could be applied for cosine as well, we see that we only just have one kind of number, which is, if we take a look, is in the same spot as C. So it's only going to be one kind of transformation that's going to happen for my cosine graph. All right. Now before that, I want to label all my numbers for A, B, C, and D. Now, if I take a look, I see that for my A, there is no number in front of the whole trig function, so the coefficient for that is going to be a 1. Then for B, there is no number in front of x, so the coefficient is going to be a 1. But we have a number for C, which is in the same spot as 90. So that means that my number for C is going to be a 90. But if we take a look, originally this was a negative, and we went from a negative to a positive. And the only way that can happen is if the 90 was also a negative, because double negatives make a positive. So C is going to be negative 90. And then D, there is no number being added or subtracted to the whole trig function, nor is outside of the parentheses. So my number for D is going to be 0. Now, if we take a look at number 1, we only just have one kind of transformation based on whatever C applies to. And if we take a look at the reference sheet over here, we see that for C, is applied for the phase shift. So that means the only change I'm going to have is the phase shift. So let's figure that out. So I'm going to box these numbers. So for my phase shift, I have negative 90, and then I divide that by my number for B, which is 1. So if I divide negative 90 by 1, I still get negative 90. So that means that my phase shift is going to be negative 90, and the phase shift follows the same rule as a horizontal shift. So we're either moving in a left to right direction, either in a left or a right direction. Now, out of those two, which one is a negative direction? If you guys said left, then you're absolutely right. So for the phase shift, we're going to be moving 90 units to the left. All right? So that's really the only transformation that's going to happen from the original graph for cosine of x. Basically, everything else is going to stay the same. The amplitude, the period. All right? So those two things are going to stay the same for this graph. So what I'm going to do now is I'm going to go ahead and graph my function. All right, so I have my max number and my min number. All right, then I have my x values. So we're going from 0 to 90, 90 to 180, 180 to 270, 270 to 360. All right, so what we're going to do is we're going to be moving, for each point, we're going to be moving 90 degrees to the left. So originally, for my original graph for cosine of x, we start at 0, 1. But since we're moving that 90 degrees to the left, I'm actually going to be starting off at negative 90, 1. So let me go ahead and graph that with a different color. So negative 90, 1. All right. And then my second point would be 90, 0. But since I'm moving in 90 to the left, I'm going to be at 0, 0. And then I have I had 180, negative 1. And then if I'm moving it to the left, it's going to be 90, negative 1. Then it's going to be 180, 0. Then 270, 1. All right, and then we're going to connect those points. So if we take a look from the original graph to the new graph, we see that each point moved 90 units to the left. All right, really nothing to it. And we really didn't need to figure out what was the amplitude, what was the period, and the vertical shift, because that didn't change. But for number 2, we may need to figure that out based on having the 2 in the front. All right, so with that being said, now for number 2, we have sine of 2x minus 90. So I'm going to label my numbers for A, B, C, and D. So A, we see that there is no number in front of sine, so my coefficient is going to be a 1. And then for B, we see we actually have a 2 in front of x, so my B is going to be 2. Then C is going to be 90. All right? All right, so the minus didn't change, so that means that this 90 would have to be a positive. And then D is going to be a 0 because there's no number outside of the parentheses. All right, so I'm going to box this up. So now I'm going to go ahead and figure out what is my information for this function. So for starters, if we take a look at the amplitude really doesn't change from the original since it's still 1. So my amplitude is still 1 unit. And then we have the period. So now the period is going to change just because we have a number for B. So for the period, we have 360 divided by B, which is 2, and that's going to give me 180. So that means that the graph is going to start to repeat itself at 180. And since we actually have a change of period, now I'm going to calculate the quarters. I want to figure out, how do I get from one x value to the next? Right? So I take 180 and divide it by 4, since we're dealing with quarters, and I end up with 45 degrees. So that means to go from one x value to the next, I'm going by 45 degrees. All right? So then if we take a look, we see we still have a phase shift going on. So for the phase shift, I'm going to take my 90 and divide it by 2, and I'm going to get 45 degrees. So that means that removing 45 degrees, and since this is a positive, removing 45 degrees to the right. All right? And then there is no vertical shift, so, all right, there is no vertical shift. So the graph isn't really gonna move up or down, and my midline, max line, and midline are gonna be the same from the original graphs. But let's go ahead and actually just label that. So if I were to label the midline, I would take my value for D and make y equal to that value, which is 0. Then for the max, I take whatever D is and add it to my number for A, which is 1. So I have 0 plus 1, which is 1. Then for my min, I have y equals to 0. And then I subtract that to my A, which is 1. And I get negative 1. So I have my max line, my midline, and my minimum line. So now I'm going to go ahead and make my graph. Right over here. Okay. All right, so now what I'm going to do is so first off I have my 1, my negative 1, and then I'm going to draw the midlines, the max line, the midline, and the min line. Okay. So now what I'm going to do is I'm going to try to figure out what are the numbers for the x values. So if you guys recall, when calculating the quarters, we're going by 45. But then we also have a phase shift for 45 to the right. So originally, I would start at 0. Okay, so to get from one x value to the next, I will go from 0 to 45, then 45 to 90, and then 90 to 135, and then 135 to 180, all right? And then for each x value is going to be shifted 45 units to the right. So let's go ahead and try to make my graph for sine. So I'm going to use the original graph for sine of x to make my graph for sine of 2x minus 90. So originally we would start at 0, 0, but since we're moving 45 to the right, I'm actually going to start at 45, 0. Then I go to 90, 1, because after that the graph goes up to the max, then down to the mid. So what I'm doing is I'm using the pattern from the original graph for sine of x to get my new graph. Then 180, negative 1. And then if we take a look, we actually have one more x value to graph from my mid. And if I go by 45, so 180 plus 45, that should give me 225. and that's going to be my midpoint. All right, so then I'm going to connect the points, and then this is going to be my new graph for y equals to sine of 2x minus 90. All right, so all we really did for number 2 was just move the graph 45 units to the right. All right, and what we did was we figured out what were the x values because of the change of period and figuring out the quarters and the phase shift. All right, so for a majority of these problems, whenever we see more than one numbers happening, then we would actually label all my information. But for problems like number 1 and for number 3, where we only just have one kind of transformation, I'm only going to just label what kind of transformation is going to happen. All right, so we take a look at number 3. We have y equals the cosine of x plus 2. All right, so I'm going to go ahead and figure out what is the transformation. So if we were to compare the setup to what we're given, we see we have a plus 2 being added to this cosine of x. So there is no parentheses happening. There's no number for c. So if we take a look, we see we have a number for d, and that d is going to represent the vertical shift. And all of my lines for the mid, max, and min are going to change. All right. So before that, let me label all of my numbers for A, B, C, and D. My A, there is no number in front of cosine, so my coefficients is going to be 1. B, there's no number in front of x, so my coefficients is going to be a 1. C, there's no parentheses going on in between x and whatever numbers, so that's going to be 0. And D, we do have a number outside of the parentheses, so that's going to be a 2. All right? And D only applies to the vertical shift. So that means that there's going to be a vertical shift happening. Okay, so let's figure out what the vertical shift is going to be for this function. So if we take a look at the vertical shift, we have, right? We have 2, and vertical, you're either moving up or down. So since this 2 is the positive, I'm going to move 2 units up. So then I'll be able to figure out my midline, my max line, and my min line. So I'm going to go ahead and figure out the midline, the max, and the min. So for the mid, it's always going to be the number that equals to D, which in this case is 2. And then we have the max. So the max, I'm going to take my 2 and add it to my number for A, which is 1. So we have 2 plus 1, which is 3. And then for the min, I'm going to take my 2 and subtract it to 1, and I end up with a 1. So now all of my points that are maximum points are going to be at y equals to 3. All of my points for the minimum are going to be at y equals to 1, and all of my midpoints are going to be at y equals to 2. So I'm going to go ahead and make my graph. All right, so I have 1, 2, 3. Actually, wait. My apologies, should be 1. This should be 2. And then this should be one more up to 3. Disregard that, because it's going in terms of halves for the y values. All right, so now I got my x values. All right, so the only thing that really changed was the vertical shift. So if I were to take a look at the original graph for cosine of x, I still have the same x values from the original. So I have 90, 180, 270, and 360. And now I'm going to draw out the lines. So we have the midline, the max line, and the min line. Okay, so now I'm going to go ahead and make my graph. Okay, so originally for my cosine, we start off at the max, which is 0, 1. But since I'm moving it 2 units up, I'm actually going to start at 0, 3. All right, and then for my 90, then I would go from max to mid, and then we would be at 90, 0. But since we're moving 2 units up, I'm going at 90, 2. And then we have 180, -1, which is my minimum. And since my minimum is at 1 for my y value, now it's going to be 180, 1. Then we're at the mid for 270, so 270, 2. And then for my max is 360, 3. All right, so this is my graph. We see that the graph from the original just moved 2 units up. So we only had a vertical shift for number 3, but let's say I wanted to figure out what were my rest of the information for cosine of x plus 2. What was my period? What are the quarters? And what was the amplitude? So I'm gonna go ahead and figure that out. So if I were to take a look at the amplitude, we see that the amplitude, my A is 1. So that means that my amplitude is going to be 1 unit. And if we take a look, we see that from the midline to the max, and the midline to the min is just still 1 unit. All right. And then we have the period. So for the period, you just take 360 divided by my B, which is 1, and I still get 360 degrees. All right. And then for the quarters, I would take 360 and divide it by 4, and we get 90. And if we take a look at this graph, we see that we still see that for each x you went up by 90, and then the graph started to repeat itself right after 360 degrees. So nothing really changed from the amplitude, the period, and the quarters from the original graph. So now let's take a look at number 4, which we may have a couple of changes based on having the 3 in the front and the 4. So first off, I'm going to label all my numbers for A, B, C, and D. So for my A, we see that A is in the same spot as 3. So my A is going to be 3. B, there really is no number in front of X, so that's going to be a 1. C, there's no number being added or subtracted to end inside the parentheses, so that's going to be a 0. And then for D, we see we have a 4 outside, further away from the trig function, and is no parentheses in sight. So that means that D is going to be 4. So these are my 4 numbers. All right. So now we're going to go ahead and figure out my information. So first off, I have my amplitude. So for my amplitude, I actually have a number for A, which is 3. And if I took the absolute value of 3, I still end up with 3 units. All right. And then we have, the period. So I take 360 and divide it by 1. I still get 360. All right. Then for the quarters, I take 360 divided by 4, and I get 90 degrees. All right. Now to figure out the vertical shift, since there really is no phase shift happening. All right, so I'm going to go ahead and figure out the vertical shift, which in this case is 4 units. So I'm going to have the vertical shift 4 units up. So now I'm going to go ahead and figure out the midline, the max line, and the min line. So my midline, I have y equals to my value for D, And if we take a look, we see that D is 4. And then for my max line, I take 4 and add it to my value for A, which in this case is 3. So 4 plus 3 is 7. So all of my maximum points are going to have 7 as my Y value. And then min, I have 4 minus 3, which is going to give me a 1. So all of my minimum values are going to be 1. So let's go ahead and make my graph. All right. So let's see if I have enough space over here. So I have 1, 2, 3, 4. Oh, we don't have enough space, so I'm gonna have to do it by ones. 1, 2, 3, 4, 5, 6, and 7. All right, and then label the X values. All right, so my quarters, I'm going up by 90, so 0 to 90, 90 to 180, 180 to 270, 270 to 360. Let me label the lines for the midline at 4. So that's my middle line. Then I have my highest line, which is at 7, my max line. Then my midline is at Y equals to 1. So I'm gonna go ahead and make my graph by using the old original graph for sine of X. So let me move this over here, perfect. Okay, so now we're gonna go ahead and get started. Now, originally we started at the midline, the midpoint. So we started off at 0, 0. And now my new mid is at 4, so now it's gonna be 0, 4. Then I go from mid to max. And originally my max was 1, but now it's gonna be 7, so now it's gonna be 90, 7. Then the next one is gonna be 180, 4, because it's the mid. And then I have 270, 1, because that's the minimum. And then I have 360, 4, which is the mid. So all I'm using is the pattern from the original graph for sine to get the new graph. Mid, max, mid, min, mid. Just like for number 3 that we use to graph for cosine. Let me just show. For cosine of x plus 2, I use the original pattern. We have max, mid, min, mid, max. All right. So if you guys still have any other questions, feel free to email me. Have a wonderful day.